In this episode, I'm going to answer the question, how do we know the age of the Earth? Now, this is a really good question every curious person should ask. It's also a great opportunity to see how science works. You see, scientists are actually able to use those extremely tiny particles called atoms to figure out how long this much larger planet has been around. Let's investigate how this is possible. Now, I'll go ahead and tell you up front, the Earth is 4.54 billion years old. You're probably thinking, that's ridiculous. There's no way we can know that. Nobody was around back then to see it formed. But if we only knew the things we could observe directly, we would actually know a lot less than we do. This is where science comes in. You see, all those facts you learn in science class, they're actually very useful in figuring out some pretty incredible things. In this case, the age of the Earth. Let's start by reviewing the atom. Remember, atoms are those extremely tiny particles that make up everything. An atom is composed of protons and neutrons in the nucleus, and around that nucleus are the electrons. The total number of protons and neutrons an atom has gives that atom its mass number. Now, while an atom of a certain element will always have the same number of protons, it can have a different number of neutrons and therefore a different mass number. For example, carbon always has 6 protons, but carbon-12 has 6 neutrons, while carbon-14 has 8 neutrons. Atoms of a certain element with different numbers of neutrons are called isotopes. Certain isotopes are radioactive while others are not. For example, carbon-12 is not radioactive, but carbon-14 is. Now, you may have heard of a process called carbon dating. This is a technique that uses the radioactivity of carbon to date artifacts such as fossils of once living organisms. Carbon-14 has a half-life of 5,700 years, which means every 5,700 years, approximately half of a carbon-14 sample will have decayed away. For example, if you start off with 100 carbon-14 atoms, you will be left with about 50 atoms after one half-life and about 25 atoms after 2 half-lives. So by knowing how much carbon-14 the living organism had, and by determining how much is left in its fossils, one can calculate how much has decayed away and therefore how old the fossil is. But carbon-14 has a relatively short half-life and can't be used to date objects much older than about 50,000 years, which means it's not useful in determining the age of the Earth. But don't worry, there are many radioactive isotopes of other elements that have much longer half-lives, such as potassium-40 with a half-life of 1.25 billion years, and uranium-238 with a half-life of 4.47 billion years. Some of these other radioisotopes can be used to date objects much older than carbon-14 can account for by a process called radiometric dating. Using radiometric dating, the oldest rocks on Earth have been determined to be about 3.4 to 3.8 billion years old. But we know these rocks originated as lava flows and sedimentary rocks, which means they come from even older rocks that have been recycled. This means that they are younger than the Earth. Tiny zircon crystals are actually the oldest known minerals that have been found on Earth. They have been dated to be about 4.2 to 4.4 billion years old. But this is where things get interesting. You see, it's safe to assume that everything in the solar system was formed at the same time as a cloud of gas and dust and a nebula collapsed. During that collapse, collisions between particles formed the sun, planets, asteroids, and everything else in the solar system. So it should all be the same age, which means we don't have to rely on just Earth rocks for its age. Back during the Apollo missions, NASA astronauts returned from the lunar surface with moon rocks that were dated to be between 4.4 and 4.5 billion years old. We also have meteorites that crash into Earth that we can date using radioisotopes. The older meteorites were dated to be between 4.4 and 4.6 billion years old. The age of the Earth has been pinned down to be 4.54 billion years old, give or take a few million years. So scientists actually use the fact that radioactive elements decay at predictable rates and employ atoms as a sort of clock to determine when the Earth and the rest of the solar system were formed. You see, that's the cool thing about science. We don't have to observe everything directly to be able to determine how and when something happened. Get a calendar of the upcoming year and it'll be able to tell you exactly what days the full moons will occur. That's because the laws of physics and chemistry, along with math, can be used to discover how things in nature happened in the past and also how they will happen in the future. There you have it. The Earth is 4.54 billion years old, and now you know how scientists figured it out.